Policy and economy in energy. Cost and benefit analysis. In this video, we'll talk about cost and benefit analysis in the energy sector. At the end of this module, you will be able to understand how to perform cost and benefit analysis, Cost-benefit analysis, or CBA, is an analytical tool for evaluating the economic advantages or disadvantages of an investment decision by assessing its costs and benefits in order to assess the welfare change attributable to it. The analytical framework of CBA is characterized by the opportunity cost, which is defined as the potential gain from the best alternative foregone when a choice needs to be made between several mutually exclusive alternatives, and a long-term outlook ranging from a minimum of 10 to a maximum of 30 years or more, depending on the intervention. Doing a proper CBA entails setting a proper time horizon. The time horizon of the CBA varies according to the nature of the investment. Energy infrastructure projects are generally appraised over a period of 20 to 30 years. Forecasting future costs and benefits in order to make estimates as accurate as possible. Adopting appropriate discount rates to calculate the present value of future costs and benefits. A public policy discount rate may be used. The rationale for choosing a public policy discount rate is to recognize the societal value of smart grid investments, taking into account uncertainty by assessing the project's risks. The use of sensitivity analysis allows to make an assessment regarding the risk of the project and the opportunity of undertaking risk-preventing actions. To perform a CBA, it's necessary to have all project input data and all information regarding possible constraints. The results obtained from the financial and economic analysis are used for risk assessment, performing sensitivity analysis, and qualitative risk analysis. A final decision is made based on summarized results. Before talking about financial and economic analysis, the notion of time in this analysis should be tackled. A direct comparison of the amount of money is only possible when two sums of money appear at the same time. When money sums occur at different times, they are usually not comparable, so their time value must be taken into account. In assessing the cost and benefit of the project, it's necessary to consider not only the size of the projected cash flows, but also to evaluate the relative value of existing and future finances, meaning to take into account the concept of time value for money. The discount rate has two important definitions. First, the discount rate is the interest rate charged to the commercial banks and other financial institutions for the loans. Second, the discount rate refers to the interest rate used in discounted cash flow analysis to determine the present value of future cash flows. Three interrelated methods to determine the project value can be used for projects' investment evaluation, taking into account the discount rate: net present value, or NPV, benefit and cost ratio, or B&C, internal rate of return, or IRR. This method considers the difference between the total discounted benefits and the total discounted costs, which gives the net present value of a project. The project should be accepted if the NPV is greater than 0, but should be rejected if the NPV is less than 0. The margin case, whether to accept or reject the project, stands when the NPV is equal to 0. This means that the project adds no monetary value. Benefit and cost ratio, B&C, can be used to determine the ratio between the present value of revenue and the present value of the cost. The project should be accepted if B&C is greater than 1. B&C equal to 1 shows that the cost equals the benefits. In this case, the ratio indicates that NPV is equal to 0. The project should be rejected if B&C is less than 1, because the costs exceed the benefits. The internal rate of return, or IRR, is the discount rate at which a project's NPV becomes zero. IRR is an evaluation criterion for project appraisal. Under a specific value of IRR, the investment should be considered not suitable. Let's consider an example of two project alternatives. Project A has a capital cost of €10,000 and a duration of construction of 1 year. It then yields a declining stream of revenues over the 5-year period. Project B has a capital cost of €15,000 and a duration of construction of 2 years. €10,000 are invested in year 1 and €5,000 are invested in year 2. It yields a revenue stream level over its 5-year lifetime. In order to compare Project A and Project B, let's display the project's NPV depending on the value of the selected discount rate. First, the schema shows that the IRR of Project B is around 16% and is lower than the IRR of Project A that is around 20%. Second, it shows which project is more profitable according to the discount rate. Under a discount rate of approximately 14%, Project B is more profitable than Project A. With a discount rate between 14% and 20%, it's the opposite. Project A is more profitable than Project B. After performing a cost and benefit analysis, the second step is risk assessment. Project risk is the uncertainty about the possibility of unforeseen situations occurring during the implementation of the project. Project risks are either good or bad surprises and all unpredictable situations. Project risk is always considered to happen in the future, something that cannot be predicted. It's not possible to have uniform policies or standards to deal with situations when there are risks to be considered. Therefore, risks need to be managed in order to minimize their impact. The science of risk management is fairly straightforward: identify, assess, treat, and monitor. These processes are closely interrelated, and sometimes only two parts of the risk management process are distinguished: risk analysis and risk management. Risk analysis involves the identification of risks and assessing their impact on the project's costs. Risk analysis can be based on sensitivity analysis. The sensitivity analysis must assess how the effectiveness of the project will change when one of the initial parameters change. The greater this dependency, the greater the risk of project implementation. Risk management is practiced by businesses of all sizes. Risk management is important because it tells businesses about the threats in their operating environment and allows them to preemptively mitigate risks. To conclude, performing a cost and benefits analysis is a time projection exercise tightly coupled with risk assessment, which is also a time projection exercise. Cost and benefits analysis use three main indicators: net present value, benefits and cost ratio, internal rate of return. All three are based on the discount rate that translates time into financial terms. Risk assessment deals with risk analysis in order to identify and evaluate risks, and risk management in order to mitigate risks. Thanks for watching.